so let's take a look at example 2 at the top of page 3. It says use the zeros and the end behavior of the polynomial function to sketch an approximation to the graph of the function f of x equals x to the third minus 4x. All right. So we're going to sketch an approximation to the polynomial function f of x equals x cubed minus 4x. Okay. So immediately you recognize, right, this is a third degree polynomial. Okay. So x cubed is the leading term. N equals 3 is the degree of the polynomial, which is odd. And the leading coefficient is invisible 1, which is odd. Or positive, excuse me. So immediately we know what the end behavior is in the graph of this polynomial function, right? This is the leading term. Odd degree, positive leading coefficient. Does the left end of the graph of this polynomial function go up or go down? Goes down. What about the right end? Goes up. Right, you get that from the graphs on the previous page, right? N degree is odd, and the coefficient is positive, so the right end goes up and the left end goes down. Okay. So we can use that information, okay, in graphing this polynomial function. Okay. All right. So to find the zeros, right, of this polynomial function, we got to set the right-hand side equal to 0 and solve for x, right? So x cubed, set x cubed minus x equal to 0, right? The right-hand side equal to 0.
Isn't it 4x?
Oh, I'm sorry. Yep, perfect. I got it written right up there on top of that. So we got two terms in our polynomial. Each contains x. The lowest power of x is x to the first, so we can factor out an x. So x times x squared minus 4 is equal to 0. And now what's in parentheses is difference of squares. We learned difference of squares in section 1.5. Math is cumulative. You bring everything from chapter 1 and chapter 2 with you to chapter 3. Okay. X squared minus 4 factors into x minus 2 times x plus 2. Okay. And now we have a product of three factors that's equal to 0. So one of those factors has to equal 0 and over the product equals 0, right? So either x is equal to 0, or x minus 2 is equal to 0, or x plus 2 is equal to 0. Well, when you solve the middle equation, you get x equals 2. And when you solve the last equation, you get x equals minus 2. Well, you'll notice, okay, that this is x to the first power. This is x minus 2 to the first power. This is x plus 2 to the first power, right? So x equals 0 and x equals 2 and x equals minus 2 are all zeros with a multiplicity of 1. Okay? So all these guys have a multiplicity of 1. So these are also the location of the x-intercepts, right? So since they all have a multiplicity of 1, okay, what's the graph going to do at each of these x-intercepts? Is it going to touch and churn at the on the x-axis, or is it going to graph going to cross? It's going to cross, right? Because it's odd. So now we can do a crude graph of this polynomial function. Okay. The x-intercepts are at minus 2, the origin, and plus 2, right? Well, we already know that the left end of the graph goes down, right? So at this x-intercept of minus 2, we know the graph goes down, right? And it can't come back up and cross the x-axis, or that would create another x-intercept. Okay? And at x equals plus 2, on the right end, the graph goes up. So at x equals plus 2, the graph has to go up. Can't come down and touch the x-axis again, or that would create another x-intercept. And now we can fill in the middle. Now remember, this is an approximation to the graph of the function. Okay. So on the left end, we know that the graph crosses the x-axis at x equals minus 2. So the graph has to come up, and it's going to cross again here at x equals 0, right? So using deductive reasoning, the graph has to come up, form a turning point, and then come down and cross at x equals 0 at the origin. And it crosses again at x equals 2. So using deductive reasoning, the graph has to come down, form a turning point, come up, and cross at x equals 2. And that is our approximation to the graph of this polynomial function. Okay. So once you know where the x-intercepts are at, and you know what the left end does and what the right end does, you can use deductive reasoning to approximate what's going on in the middle. Okay. The left end is going down, the right end is going up, and the graph is crossing at x equals minus 2, 0, and plus 2. Okay. Any questions on that, ladies and gentlemen? Okay. All right, so let's take a look at example 3. This one I provided a little coordinate plane. Okay. We're going to sketch the approximate, right? Sketch the polynomial function f of x here. So we got to repeat what we've already done. So we have f of x equals x to the 4th minus 3x cubed plus 2x squared. So immediately we know that x to the fourth is the leading term, right? It's the term with the largest power of x. N equals 4 is the degree. And 1, the invisible 1 in front of x to the fourth is the leading coefficient. So given that the degree is even and the leading coefficient is positive, we know what the end behavior is in the graph of this polynomial function. Right? What happens on the left end? What happens on the right end? Just like a parabola does, right? Goes up on the left end, the parabola, the squaring function, right? Just like the squaring function, right? The left end goes up, the right end goes up. Okay. And now we got to find the x-intercepts of this polynomial. So to find the x-intercepts, right? Find the zeros. You set the right-hand side polynomial function equal to 0. So we have x to the fourth minus 3x cubed plus 2x squared is equal to 0. So again, we got 3 terms involving x. Each term involves x. The lowest power of x is 2. So we can factor out an x squared. So x squared times x squared minus 3x plus 2 is equal to 0. And then this trinomial inside parentheses factors, right, with whole numbers. You have x squared times x minus 1 times x minus 2. Everybody agree with me? Okay. And so now we have a product of 3 terms, or we have a product of 3 factors that equals 0. So one of those factors has to equal 0. Either x squared is equal to 0, or x minus 1 is equal to 0, or x minus 2 is equal to 0. Well, in the first one, you take square root of both sides, you get x equals 0. Second equation, you add 1 to both sides, you get x equals 1. Third equation, you add 2 to both sides, get x equals 2. So these are the zeros of our polynomial function, right? Which is also the location of the x-intercepts. Now, the 0, x equals 0, has what for multiplicity? 2, right? Because it's x squared. The exponent on the x is 2. So this has a multiplicity of 2. All right, x equals 0 has a multiplicity of 2. And x minus 1 is raised to the first power. X minus 2 is raised to the first power. So these 2 zeros have a multiplicity of 1. Okay? So now we basically have the information we need to graph this polynomial function. Okay. So listing out the zeros, right? So it looks like we don't have anything less than 0. Let me redraw this. So we have an x-intercept at x equals 0, one at x equals 1, and one at x equals 2. We know that the end behavior is the left end goes up, the right end goes up, right? So from this last x-intercept, the graph has to go up. Can't come down and touch the x-axis again, or that create another x-intercept. And here at the origin at x equals 0, the graph has to go up. Okay. Otherwise, you can't come down and touch the x-axis or create another x-intercept. All right. Now, at x equals 0, we have a multiplicity of 2, right? So at x equals 0, does the graph cross the x-axis or touch and churn? Touch and churn, because it's even. Multiplicity is even. At x equals 1, x equals 2, the multiplicity is 1. Does the graph cross or touch and churn? Cross, right? So at x equals 0, we said it touches and churns, right? So it's got to do something like this, right? So I'm redrawing things a little bit, okay? Touch and churn at x is 0, and the reason it's above the x-axis because we know the left end goes up. Okay. Now we know that the graph crosses at x equals 1. So the graph has to come up, form a turning point, and come down and cross at x equals 1, right? And we know the graph crosses at x equals 2. And it goes up on the right end. So the graph's got to come down, form a turning point, come up, and cross at x equals 2. And now we've sketched, okay, the polynomial function at the top of page 3.